My name is Dr. Godwin Obono. You're welcome to this channel, Medical Science Lecture Room. Here we try to keep you informed on science and medical matters. Today's discussion will be mathematics tutorial. The topic is trigonometry. Trigonometry is a branch of mathematics that make use of specific functions called trigonometric functions to solve problems of triangles. What this means is that if you're given a triangle, for instance, if I have a triangle like this, I will say triangle A, B, C. If we take this angle, for instance, as angle theta, and you're asked to find either of the side of the triangle, whether side AC, side BC, side BAB, whichever side you're asked to find. In that case, you may have been given either of the two sides and one side may not be given, or you're given one of the triangles, like I have represented this angle, and this angle is not given, and you're asked to find this angle. Already you know this angle is known as 90 degrees. So, if you're asked to find either of the sides of the triangle or the angle of this triangle, you will be thinking of trigonometric functions. So it means therefore that for every problem that has to do with the triangle and you are asked in any examination to find either of the sides or either of the angle, you should be thinking of trigonometric identities, or you should be thinking of trigonometric functions. Basically, we have sine, cosine, and tangent. That's why it is called trigonometry. Trigonometry because its functions are specific for sine, cosine, and tangent. We also can have what we call the secant, the cosecant, and the cotangent. So what I will be doing is simply to tell you what the sine, cosine, tangent, secant, cosecant, and cotangent are, after which we'll take some basic questions. Today, like I said earlier, we will anchor our problems on trigonometric identities. Let's try to define these specific functions. Sine, for instance, sine is always defined as opposite all over hypotenuse. Opposite all over hypotenuse. The sine of any angle is always defined as opposite all over the hypotenuse. The cosine of any angle is defined as adjacent all over hypotenuse. And the cotangent the tangent of any angle is defined as opposite all over adjacent. Basically, these are the definitions of these three specific functions. So, if you have a triangle, let's say a right angle triangle, for instance, it's a right angle triangle. It is a right angle triangle because at this point the angle is 90 degrees. And here, let's say the triangle is triangle ABC. Why this angle here is 90 degrees? A triangle is said to be right angle triangle if one of the angle is 90 degrees. So at this point the angle is 90 degrees. Now we now have here, let's say the angle is theta. This angle is theta, and you're asked to find the sine of theta, or the cosine of theta, or the tan of what theta. So you need to remember this. For me to, supposing I say that this side, this is a triangle, let this side that faces this angle be small letter A, and this will be small letter C, and this will be small letter what B. And now I want to define sine. For instance, sine theta. I want to define sine theta. Now, because the angle is theta, this has to be equal to the opposite of theta. We ask ourselves, what is the side that faces theta, that is opposite of theta? You can see that this is a side that faces the angle theta. And so we say that AC, side AC, all over the hypotenuse, which is side AB. And of course, this will be equal to B all over 1C. If we want to define cos theta, this has to be equal to adjacent of theta all over the hypotenuse. The adjacent of theta, in this case, remember that this is always the hypotenuse. The longest side is the hypotenuse. Now this is defined as the line that is side that is opposite to theta, and so the remaining side has to be what? Adjacent to what? Adjacent to what? Theta. And so this has to be the line BC all over the hypotenuse what? AB. And of course that will be equal to A all over C. Now if we want to define tan, that will be tan theta equal to opposite, we said opposite all over adjacent. Now the side that is opposite to theta is of course AC. That will now become AC all over what? The opposite all over adjacent all over BC. And that of course is equal to B all over what? A. So you can see this is how to describe sine, cosine, tan with respect to this triangle. Remember that if I take for instance this angle to be what? Alpha. Here at this point, the side that is opposite to angle alpha will be what? The side BC or line BC. Line BC, which was adjacent of theta, is now opposite to what? Alpha. Now line AC, which that was opposite, line AC is opposite to theta, but line AC is adjacent of what? Adjacent to what? Alpha. Well, this line remains the same as the hypotenuse. So this is how you can quickly define these trig ratios: sine, cosine, and tan. Remember, the foundation of trigonometry is on what? These three functions. These three functions: sine, cosine, and tan, which is why it is called trigonometry. Now, by extension, we'll be looking at what we call the secant, the cosecant, and the cotangent. Now, the secant, which is abbreviated as sec, is always defined as the reciprocal of cosine. In other words, 1 all over cosine. So the secant of any angle is always equal to 1 all over the cosine of that angle. So if I say sec theta, it has to be equal to 1 all over cos theta. If I say sec alpha, this has to be equal to 1 all over cos alpha. So it's important to know that the secant of any angle is equal to 1 all over the cos of that angle. Now let's also look at the other function. If we say cosecant is always abbreviated as cosec. So if I say cosec theta, cosecant is generally defined as 1 all over sine. 1 all over sine. So if I say cosec theta, it has to be equal to 1 all over sine theta. If I say cosec alpha, that has to be equal to 1 all over sine alpha. Again, we have cotangent. Cotangent is always defined as 1 all over tan. 1 all over tangent. It means that cot theta will be equal to 1 all over tan theta. It also implies that cot alpha is equal to 1 all over tan alpha. So by extension, we have 3 other specific functions. These are more or less a combination of the 3 basic trigonometric functions. So we have secant, we have cosecant, and the cotangent. Like I said, secant is 1 all over sine theta, 1 over cos theta, and we said cosecant is 1 over sine theta, and then we have cotangent as 1 over tan theta. So it's very important, these 6 specific functions should be noted. Now, understanding of these 3 specific 6 functions will help you to handle any problem that concerns trigonometric identities. Now let's begin with some examples of Let's take an example of a trigonometric identity. Supposing you're asked to show that sine squared theta plus cos squared theta is equal to 1. The question is, prove or show that sine squared theta plus cos squared theta is equal to 1. How do you handle this? First, I will say solution. Consider a triangle ABC. Remember, we said that trigonometry is a branch of mathematics whose application is basically on triangles. So I will now say consider a triangle ABC. Supposing we have a triangle ABC, and the angle at this point, let's assume is theta, since the question here carries more theta. So let's say theta is the angle at this point, and our triangle is triangle ABC. And so we want to show or prove that sine squared theta plus cos squared theta is equal to 1. First, you have to say sine theta. Remember the formula here, or the question given to us has sine theta, cos theta. So we take first sine theta. Again, please, having said that this triangle is triangle ABC, let us further define the sides. Now, if this side BC is the side that faces the angle A, we can possibly say that let this be small letter a, and this side AC is facing the angle B. Let this side therefore further be defined as small case letter B, and then this side, let it be small c, where this one is capital was C. Now we have sine theta is equal to, remember we have defined what sine is. We say sine of any angle is equal to opposite all over hypotenuse of that triangle. Now in this case, what is the opposite of this angle theta? The opposite is this line, and so this is B all over the hypotenuse, which is what C. Remember that the opposite is line AC all over the hypotenuse, line AB, and so line AC is letter, we represented it as small letter B all over what? The small letter C, or small letter C. And then we have, sine theta equal to B all over C. Now remember that the formula or the question has sine squared theta. So it means therefore that here, having known sine theta, we cannot attempt to square it. That will be sine squared theta. If you square sine squared theta, that will give you B all over C, all raised to power 2, and of course this will be equal to B square all over what? C square. B all over C is sine theta. By the time you square sine theta, it means that this answer should be squared. If you square this answer, you're going to have B square all over C square. Now we are done for sine square theta. Let's equally do the same for cos. Cos theta is equal to, from this triangle, cos theta will be defined as, remember, fundamentally, cos is defined as adjacent all over hypotenuse. So in this case, what is the adjacent of theta? This side BC is the adjacent of theta, and so we say that is A all over the hypotenuse, which is of course C, letter C, small letter C. And so again, what we were given, we were not given cos theta, rather we were given cos square theta. So what I have to do at this point is to square this answer. So this becomes cos square theta equal to A all over C, all raised to power 2. And this will give us A square all over C square. So cos square theta is equal to A square all over C square. And now recall, we were asked to find or to show that sine squared theta plus cos squared theta is equal to 1. So we want to find what the answer is. The square of sine theta plus the square of cos theta. What we want to prove that the answer will be 1. Now, having known what sine squared theta is and we've known what cos squared theta is, we bring the two answers together. And so for sine squared theta, we saw the answer was b squared all over c squared. And then cos, this has to be plus. Cos squared theta, the answer we got was a squared all over c squared. You can see that we have two fractions. This is one of the first fraction and this is the second fraction. At this point, we have to look for the LCM. Remember, in mathematics, once you have two fractions separated by a plus or minus sign, what you're going to do is to find the LCM. Now, if I look for the LCM will be, of course, the lowest common multiple. And so that has to be small letter c, which is c squared. And now c squared into itself, in other words, c squared divided by c squared, that will give us 1. 1 times this, that will be b squared. And plus c squared. Sorry, plus a squared. C squared into this will be 1. 1 times this, that will give us what? A squared. So what we have at this point will be what? B squared. We have a squared plus b squared all over c squared. Please take note, it's the same thing. Even if I decide to bring this first, b squared plus a squared, it is the same. So what we now have is that this is equal to sine squared theta plus cos squared theta is equal to a squared plus b squared all over c squared. Remember, the intention is to show that this, the whole of this should become 1. How do we achieve that? How do we change this to 1? Now we can say, recall that from Pythagoras, remember that if we apply Pythagoras, what other rule that can be applied to a right angle triangle is a Pythagoras theorem. And so if you apply Pythagoras theorem, that's a rule or a theorem that will enable you to find either of the sides of a right angle triangle. It will not help you to find either of the angles, but it will provide solution to any of the sides. So supposing we want to apply Pythagoras theorem to find the side AB. Remember, according to Pythagoras, he said that the square of the hypotenuse of any triangle is equal to the sum of the square of the other two opposite sides. That's the rule. So the square of this side, of course this side is AB. If you square AB, that has to be equal to the square AC squared plus BC squared. Pythagoras theorem says the square of the hypotenuse of any right angle triangle is equal to the sum of the square of the other two opposite sides. And so that's what I have applied here. The square of this side is equal to the square of this side plus the square of this side. Of course, this side is the hypotenuse. We had it as c squared, and this will be equal to what? A squared plus, remember that our AC is b squared plus a squared. And of course, if you rearrange it, it's the same thing as c squared equal to a squared plus b squared. So the other definition of the side C, the small letter c, which is the same as AB, is equal to a squared plus b squared. Now, if we replace this, in other words, substituting c squared in sine squared theta plus cos squared theta. If you substitute this c squared in this, remember that sine squared theta plus cos squared theta, what we had then was a squared plus b squared all over c squared. So in that case, if having known that another definition or another expression for c squared is a squared plus b squared, at this point, instead of having a squared plus b squared, we may decide in place of a squared plus b squared, we may decide to put c squared, because c squared is the same as a squared plus b squared. And so this is c squared all over c squared. And when you have, of course, the numerator and the denominator are the same, it means they can cancel. And if they cancel, what you're going to have is 1. Hence, we will say that sine squared theta plus cos squared theta is equal to 1. Proved. You can say it has been proved. So when we say trigonometric identity, it means that the examiner may either ask you to prove or to show that what you have at the left hand side of the equation is equal to what you have at the right hand side of the equation. Your concern is to the examiner. In that case, the examiner had given you the answer. The examiner has simply told you that when you had these two, the answer will be 1. The question now is that prove or show how the examiner arrived at that 1. That is just simply the intent of that question. Please, let's take another example. Let's take other examples. Now we have a number of equations on the board. These are examination questions. Now the first is prove that the square root of 1 minus cos squared theta all over cos theta is equal to tan theta. So the examiner, now look at this, is the first question. The second is this. Now the examiner wants us to show that the square root of 1 minus cos squared theta all over cos theta is equal to tan theta. What that implies is that the examiner has given us the answer. You are now asked to show how the examiner arrived at that answer. Or that tan theta is equivalent to what? 1 minus cos squared theta, the square root of 1 minus cos squared theta all over cos theta. Now, the question is, can we recall what tan theta is? Earlier, I told you that the tan of any angle is equal to opposite all over what? Adjacent. That's what I told you earlier. You should also recall that tan is also expressed as sine theta all over cos theta. These are the two definitions for the tangent of any angle. So if you have any angle, let's say sine alpha, sine gamma, sine beta, whatever the designation of the angle is, it's important for you to know that the tan of that angle must always be equal to the opposite of that angle, the opposite to the angle all over the adjacent of that angle. And also the sine of that angle all over the cosine of that angle. In this case, this formula gives us a relationship between the three trig ratios. Remember, the trig ratios are 3: the sine, the cosine, and the tan. So by the time the formula that combines the 3 of them is the formula, the relationship of tan theta, the relationship of tan to the sine and the cos, and that gives you what? Tan theta. Now, let's answer the question now. Solution. The first question says the square root, this is a very simple question, the square root of 1 minus cos squared theta all over what? Cos theta. We are asked to solve this such that the answer should be tan theta. Now I will say that this is solution, and that's what I've written on the board. Now first, recall what is 1 minus cos squared theta. For us to answer this, we have to recall that sine squared theta plus cos squared theta is equal to 1. What this means tells you is that when your equation is given to you, you can actually recall another expression or identity that is known internationally. You use it to solve the problem given to you. Like we have done this earlier. That was the first question, that we proved that sine squared theta plus cos squared theta is equal to 1. Now, even if this angle, for instance, this angle was alpha, I would have changed this to sine alpha cos alpha. If this angle was A, I would have changed this to sine square A plus cos square A. And so at this point, I will try to make sine theta the subject of the formula. Why am I trying to do so? The reason is that I am thinking of what to replace, what to remove, how to remove this one, and then replace with something that is its equivalent. So if I'm to substitute 1 minus cos squared theta, I have to bring in there what is its equivalent. And so if I say sine squared theta equal to 1 minus cos squared theta, it means that I'm trying to isolate or make sine squared theta the subject of the formula. And what that implies that this cos squared theta has to be transferred to the right hand side of the equation. Of course, if that happens, the sign changes to what? Minus. So we're going to have 1 minus cos squared theta. And so at this point, we can now say that the square root of 1 minus cos squared theta all over cos theta can now be equal to the square root of, instead of 1 minus cos square theta, we can have the what? Sine square theta. Having established that sine square theta is the same as 1 minus cos square theta, so we have the permission to replace 1 minus cos square theta with sine square theta, and that will now be all over what? Cos theta. And this is equal to, remember, this is square root, and this inside within it, what we call the radicand, within it is sine square theta. Now the square root of sine square theta is sine theta, and that will be all over what? Cos theta. Remember, I did say that sine theta all over cos theta is the same thing as tan, and so this is equal to what? Tan theta. Hence, you conclude that 1 minus cos square theta all over cos theta is equal to what? Tan theta. You see, simple. We've solved that. So anytime an identity, an expression is given to you, and you're asked to show how that resulted to what you have at the right hand side, you must always remember other functions that will help you to arrive at that answer. Like I recall sine square theta cos square theta. If I couldn't, then this problem cannot be solved. So that's the first one. Now look at the second question. The second question says we should show that 1 minus sine theta, this bracket open and close, 1 minus sine theta, bracket open and close, 1 plus sine theta all over sine square theta. We should show that that's equal to cot square theta. Cot square theta. This again, what is, for us to solve this, the second question, please. Question number 2, we want to, the question is 1 minus sine theta, 1 plus sine theta all over sine square theta. The question is, we should show that, the question is, prove that 1 minus sine theta, bracket open and close, times 1 plus sine theta, bracket open and close, all over sine square theta is equal to cot square theta. So the question now is that what is cot? If you have to remember what is cot, remember that cot is always 1 all over what? Tan. So if we have cot theta, so at this point, what we have to do here is 1 minus sine theta. Those two brackets tells you that this bracket has to be expanded, and so you need to use the content of this bracket to multiply the content of the other bracket. And so in doing that, I will say 1 times 1, of course that will be what? 1. 1 multiplying this, that will give us plus sine theta. 1 minus sine theta times this will give us minus sine theta. Minus sine theta multiplying this, that will be minus sine square theta. I know that will be all over sine square theta. So I have removed the bracket by simply doing what? Multiplying, using this to multiply the other bracket. And this is what we have. Now at this point we are having plus sine theta minus sine theta. Of course that will be 0. It simply means sine theta minus sine theta. That gives us 0. So we have 1 minus sine square theta all over sine square theta. And this is equal to, now if you remember again, we said recall that sine square theta plus cos square theta is equal to 1. At this point, if I make cos square theta the subject of the formula, that will be 1 minus sine square theta. You remember this. So if you recall that sine square theta plus cos square theta is equal to 1, and you try to make cos square theta, why am I isolating cos square theta? I am isolating cos square theta because I want to see how I can remove minus 1 minus sine square theta and replace with its equivalent. So having recalled that this is so true for this, I can now say this is equal to, in place of 1 minus sine square theta, I can now have the cos square theta all over what? Sine square theta. Now you see this is cos square theta all over sine square theta. Now, how does it look like? Look at how the appearance of this. This tells us is cot. Remember that cot, the cot of any angle is 1 all over tan theta. And of course, you know that tan theta is the same thing as sine theta all over cos theta. And of course, this will be equal to cos theta all over sine theta. Therefore, it means that cot theta is the same thing as cos theta all over sine theta. And what are we seeing here? You see that cos theta all over sine theta. The only thing is that it is being squared. And so this is the same thing as cot square theta. Because it is cos all over sine. Cos all over sine is cot. And the cot is being, because the cos is squared and the sine is squared, so the cot has to be what? Squared. Please take note. Cot is equal to 1 all over tan theta. And this is equal to 1 all over sine theta all over cos theta. Sine theta all over cos theta represent tan. And then when you further express this will give you cos theta all over sine theta. And then cos theta all over sine theta, of course, that will be cotangent. And in this case, what we have in our problem, the cos and all over the sine, they are both, the cos and the sine have been squared. Therefore, the cot has to be squared. And that's why we are having cot square theta. Remember that the question is, show that this is equal to cot square theta. And exactly that's what we have done at this point. Look at the third question. The third question is, we should show that sine theta all over 1 minus cos square theta. We've been asked to show that that's the same thing as cosec theta. Sine theta all over 1 minus cos square theta is equal to cosec theta. Now this is equal to sine theta all over 1 minus cos square theta. Of course, that is the same thing as sine square theta. From sine square theta plus cos square theta equal to 1. If you make sine square theta the subject of the formula, you will have 1 minus cos square theta. So sine theta all over sine square theta, that will give us what? Once sine will cancel itself here and it will cancel 1 here, that will be 1 all over sine theta. And 1 all over sine theta is equal to what? Cosec theta. And see, we have proved that. Now the final question is sec theta minus tan theta, sec theta plus tan theta is equal to 1. We are asked to show that this sec theta minus tan theta multiplying what? Sec theta plus tan theta, that this will be equal to 1. How do we go about that? Of course, whenever you have two brackets like this, it means that you have to multiply the two brackets. So sec theta multiplying this will give us sec square theta. And this multiplying this will give us plus sec theta tan theta. You now use this minus multiplying this, that will be minus sec theta tan theta. This multiplying this, that will be minus tan theta. And now this will now be sec square theta, sec theta tan theta minus sec theta tan theta will be 0. That will be minus now tan theta. Now here, of course, this multiply, that will be tan theta square place, tan square theta. Now we can, at this point, what is sec? Sec is always 1 all over sine. So 1 all over cos. So if it is sec square theta, it has to be sec, it has to be cos square theta. Then minus What is tan? Tan itself is always what? Sine theta now all over cos theta. That, but because it is squared, it has the sine will be squared, the cosine will equally be squared. And so at this point, you look for the LCM. The LCM of this will be cos. We're going to have what? Cos square theta. Cos square theta into itself, of course, is 1. 1 times 1, that will be 1, minus. Cos square theta to this will be 1. 1 times this, that will be what? Sine square theta. And this is equal to 1 minus sine square theta all over cos square theta is what we have at this point. But remember that 1 minus sine square theta again is the same thing as cos square theta. And that has to be all over what? Cos square theta. And of course this will cancel and you're going to have 1. You can see, because the question is, show that sec theta minus tan theta multiplying sec theta plus tan theta is equal to 1. And that's what we have shown. So this is solutions to these identified problems. At this point, if you have any problem, any question, please drop your comment on the comment section, and please don't fail to subscribe to this channel. Don't also like the channel, like this video if you find it of value, share it. Thank you.